I'm Jackson Yost, and this is my forces video problem. Question. A box is filled with watermelons and weighs 10 kilograms. It is put on a flatbed truck which is initially moving at 21 meters per second. The driver applies the brakes and the truck decelerates at a constant rate and stops at a distance of 53 meters. What is the minimum coefficient of friction between the crate and the truck that is required to keep the crate from sliding? Then the driver makes a stop at the grocery store and drops off 3 kilograms of the shipment of watermelons. The driver wanted to make sure the box wouldn't slide, so he sanded down the bed of the truck to a new coefficient of static friction of 0.7. What is the shortest distance the truck could stop in if it was traveling at 29 meters per second and was decelerating at a constant rate? The first step to solving any problem is to draw a diagram. I made a truck with a box on top of it, and then a force diagram. So you have the force of gravity pointing downward, the normal force perpendicular to the surface of the bed of the truck, the force of the truck to the right because it is accelerating right when the truck decelerates, and the force of static friction going against motion. Then you have to list your known and unknown values to know what to solve for. For the first strip, your known values are mass, 10 kilograms, initial velocity, 21 meters per second, and displacement, 53 meters. Unknown values are time, acceleration, and what you're trying to solve for, mu. For the second trip, mass is 7 kilograms because 3 are getting taken away, the initial velocity, 29 meters per second, and mu, 0.7. Unknown values, time, acceleration, and what we're trying to solve for, displacement. Now this is the equations list, all the equations you'll be using in order to solve for these unknown values. The displacement equation, the acceleration equation, the sum of the forces equation, and the force of static friction equation. The sum of the forces equation comes from Newton's second law, and you can use these two equations in order to come up with a new equation, force of static friction equals mass times acceleration, because the force of static friction is a force. Now that we have all of our values, we can go in to start solving the equation. For the first half, we want to start out by solving for time because we have all of the other values except acceleration and time, and we can use acceleration as negative 21 meters per second over time, and so we could put acceleration in terms of time so that we could solve for the variable time. So we put it into the displacement equation and get that time is 5.05 seconds. And our next is to solve for acceleration. We just solved for time, so now we are able to solve for acceleration and get negative 4.16 meters per second squared. Now that we have all the values we need, we can go in to start solving the force of static friction equation to get mu. First, we have to solve for the force of static friction and use the new equation we created, mass times acceleration. So we have 10 kilograms and the acceleration that we solve for to get 41.6 newtons. Now, the only unsolved variable in the equation is the normal force. The normal force is mass times gravity because it's the same thing as the force of gravity. We get 10 kilograms times 9.8 meters per second squared, and we get 98 newtons. Now that we have all the values, we could solve for mu. We plug that in, and we get mu is 0.42. Now, we go back to our question, and now we can try and solve for the second half. I'll repeat the question again. Then the driver makes a stop at the grocery store and drops off 3 kilograms of the shipment of watermelons. The driver wanted to make sure the box wouldn't slide, so he sanded down the bed of the truck to a new coefficient of static friction of 0.7, which is the shortest distance the truck could stop in if it was traveling at 29 meters per second and was decelerating at a constant rate. So we go back to our known and unknown values. We have mass, 7 kilograms because 3 are taken away. The initial velocity, 29 meters per second. Mu, 0.7, a new mu value. And we're trying to solve for time, acceleration, and displacement. All equations that we have. So we go to the second trip. To solve for acceleration, we use the combination of the sum of the forces and the force of static friction equation. So mass times acceleration is less than or equal to mu times the normal force. And mass is actually independent in this equation, so you can cancel out mass and have acceleration equals is less than mu times gravity. So then you solve for acceleration and get 6.86 meters per second squared. Now that we have acceleration solved for, all we need is time. So we have negative 6.86 meters per second squared is equal to 29 meters per second divided by time. We get that time is 4.23 seconds. So now we have acceleration and time and the initial velocity. That's all we need to solve for displacement. Plug that into the displacement equation and get 62.9 meters. So now we've solved for both, and we can write out our solutions. The minimum coefficient of static friction between the truck and the box is 0.42. The shortest distance the truck could stop in is 62.9 meters. Thank you.